Hi everyone, welcome to Integral Calculus. Today we explore lesson 7.3, integration by trigonometric substitution, part 1. Number 1, the idea. If we have the integral of x root x squared minus 4 dx, then we can do it using the u substitution. U equal x squared minus 4 and du is 2x dx. So half of du is x dx. Yay! However, if it is written as root x squared minus 4 over x dx, the integration of this one, we cannot use the u sub because it's not possible to turn the integral of fx dx into the integral of gu du. Well, if u sub fail, next thing we do is integration by part. We're going to split the integrand into two parts. Okay, let u equal root x squared minus 4 and dv is 1 of x dx. However, when we do this, du is a little more complicated. So it's 1 over 2 root x squared minus 4 multiplied by derivative of the inner function 2x. Well, the derivative cannot be complicated. It doesn't work. How about switching the u? We cannot u to be 1 over x and dv to be root x squared minus 4 dx. The problem with this one is that how do we figure out the antiderivative? See? So to solve this problem, we have to figure out how to get rid of the square root. This is the square root here. Lucky for us, we can use trig identity to get rid of that square root. We just have to let the radical become a trig substitution. And the identity is, we can use this. Well, it does look similar to secant square theta minus 1 equal tangent square theta. Once we use the identity, the method is called trigonometric substitution. 2, integration by trig substitution. Let's take a look at the problem. Integral of root x squared minus 4 over x dx. We can let x to be 2 secant theta. For, well, we want the function to be a 1-to-1 because we want to go back and forth. So we restrict the angle to be from 0 less than equal to theta less than pi over 2 or pi less than equal to theta less than 3 pi over 2. Dx is 2 secant theta tangent theta d theta. And then we also see that root of x squared minus 4 is root of 2 secant theta square minus 4, which is root of 4 secant square theta minus 4, and secant square minus 1 is tangent square. So root of 4 tangent square theta. We have 2 absolute value of tangent theta. Well, it is terrible to work with absolute value, but lucky for us, because the angle is between 0 and pi over 2, or pi and 3 pi over 2, tangent of that angle is positive, so we can get rid of the absolute value. 2 tangent theta. Now, with the trig sub, we have the integral 2 tangent theta, x is 2 secant theta, and dx is 2 secant theta, tangent theta d theta. 2 secant and 2 secant cancel out, so we have integral of 2 tangent square theta d theta. And from the previous lesson, the integral of tangent square is tangent theta minus theta plus c. Now we have to write theta in terms of x. And to do that, we used the trig substitution. X equal to 2 secant theta. From here, secant theta is x over 2. Draw out the right triangle. This is the angle theta. Secant is 1 over cosine, so that it would be hypotenuse over adjacent. X over 2, using the Pythagorean theorem, this is square root of x squared minus 4. And so we have 2 tangent opposite over adjacent, root x squared minus 4 over 2 minus the angle theta is arcsecant, or secant to the negative 1 x over 2 plus c. Distribute the 2 and we have root of x squared minus 4 minus 2 secant to the negative 1 x over 2 plus c. Beautiful. Let's take a look at the general trigonometric substitution, so we can do more example later on. Given the expressions square root of a square minus x square, square root a square plus x square, square root of x square minus a square, then there are trig substitution that we can use. For the root of a square minus x square, we use the substitution x equal to a sine theta, and we restrict the angle theta to be from negative pi over 2 to pi over 2 to make the function x equal a sine theta a 1-to-1 function. And another reason why we restrict the angle theta is because the absolute value of cosine theta will just be cosine theta. Cosine of the angle theta is positive from negative pi over 2 to pi over 2. So if the expression is square root of a square plus x square, then the trig substitution is x equal a tangent theta, and the angle is between negative pi over 2 and pi over 2. Another expression is square root of x square minus a square. the trig substitution here, x equal a secant theta. And we just did a problem like that in which we restrict the angle to be between 0 and pi over 2 or pi and 3 pi over 2. Thank you for watching. I hope you found the content useful. Please like, subscribe to help the channel grow. I will see you in the next video.